Right, so industry trends. So Eugene, what's happening in the fixed income market that make it an ideal time for AI to be part of the solution?
Fixed income is a very different animal compared to some of the other asset classes, like equities or FX. When you look at equities, you're looking at a few thousand tickers. It's a space that has been long electronified, and efficiency, speed of execution is obviously a generation ahead of fixed income. When you look at the bond markets, there are millions of securities that sort of all act and feel very differently. Munis work and feel very differently from mortgages, from corporate bonds, from bank loans, and so on. But fixed income has been catching up. There's a lot more electronification in the space. There's a lot more firms that are becoming a lot more sophisticated when it comes to data and tools and analytics. And as a result, firms are looking for better solutions, for data, for tools that help them stay competitive in this space. So that's one of the industry trends. I would also say, in the last couple of years, firms are trying to do a lot more with less people, with less resources. As a result, they're looking for more automation, for more data-driven capabilities.
I just want to add to that. One of the things that we hear a lot, especially in the municipal marketplace, is the demand for more and more data. And to leverage on Eugene's point, there's demand for more data, but at the same time, there's the recognition that there are less human resources to utilize that data. So if you have lots of data and you don't have the tools or the people to make information out of the data, it's useless. And so it's another example of where, with the introduction of more and more data, limitations on the number of people that you're going to, the demand for technology and the use of AI has become more and more paramount.
Yeah, and I would say, just adding on to that, the availability of data in the market has reached unprecedented levels, as well as the availability of computing power, fast computing power, to be able to utilize that data and perform analytics off of it.
Eugene, can you talk to us about the history of Solve and Solve PX? And Solve did not just get into the AI game this week, right? It's doing a lot of things with natural language processing, et cetera. So that's right.
Solve was founded in 2011, and our mission has always been around price transparency, for making markets more efficient and more equitable. Our initial product focused on aggregating quotes across many asset classes, quotes that are exchanged between market participants, between the buy and the sell side, in highly unstructured ways. As a result, we were able to deliver unprecedented levels of price transparency. We're delivering on the order of 20 million quotes across all the key asset classes in fixed income, corporates, municipals, all forms of securitized products, bank loans, credit default swaps, and private credit, and many others. At the same time, as we engage in conversations with clients, we've learned, and internally we've coined a phrase, that some clients need the data and some clients need the answer. So some clients, they're incredibly sophisticated. They have systems and tools and people that are capable of ingesting as much data as possible and turning that data into insights and trading ideas. But at the same time, many clients do look to us to help them provide the answer. And Solve PX is meant to be the answer. It's meant to be our prediction of where trades are going to happen. And we are incredibly excited to roll out Solve PX in our first asset class, which is municipal bonds. And then eventually follow the same playbook across the spectrum of our asset classes that we cover. The other thing I want to mention is AI has always been part of our DNA. When it comes to solve quotes, our quotes aggregation platform, we've from day one we've leveraged natural language processing to aggregate quotes from highly conversational and very unstructured messages. We've leveraged AI for data cleansing. As you know, another thing we like to say internally is that the resulting data is often cleaner than the data that's coming into the platform. There are all sorts of algorithms that happen behind the scenes that fix the originating data, that help reclassify things like prices, spreads, and yields. And now we are also leveraging AI and machine learning to deliver our predictive pricing product, which is SolvePX, which is meant to predict where trades are going to happen across different sizes and sides of the market.
Now, I would just add to that, Solve really does have a rich tradition in utilizing artificial intelligence across its products. Eugene articulated well what we've done on the quote side and what we're doing now with Solve Price. In addition to that, looking at the municipal market space, aside from the quotes and the Solve Price that we've generated now, we've utilized it historically to generate proprietary data and control its accuracy, particularly with our obligor credit database that we append an obligor to every bond in the market, as well as the utilization of AI in our scale writing platform, where we come up with new scales for new issues, municipal issues that come to market. The system is based on looking at comparables across the market where deals have traded, priced in the market similar to the deal that our client is looking to price. So they're looking at the credit and structural characteristics of that transaction. Our system finds comparables, builds a yield curve, but there are certain times in the market where there are points along that yield curve where we don't have observable market data. And in those cases, we're able to utilize artificial intelligence to fill those gaps in the yield curve and produce a better product for our clients.
In fixed income world, right, what is AI? What is AI and what are the use cases, right? Efficient tool to add to post-trade processing? Is it a trade idea generation? What should AI be for fixed income?
Sounds good. In the context of financial markets and fixed income in particular, AI is being used in two kind of specific use cases. One has more to do with sort of the recent advances in the large language models, specifically in their ability to interact with various content, right? Things like structure and digitize deal documents or research, where you're able to be a lot more efficient when it comes to aggregating kind of various financial metrics or understanding how complex legal documents work. The other piece is what Solve has been focusing on, are more quantitative techniques which rely on various data sets to generate predictive analytics. So in the context of Solve Price, we're leveraging kind of these massive data sets, right? So it's relying on three key data sets, one being our proprietary quotes data, the other being trades, and the third reference data. And it looks at hundreds of characteristics, so 300 different feature inputs across these three key data sets to fill the gaps in the data and generate where trades are going to happen for over 900,000 municipal bonds.
Where are you in the journey of implementing any of these types of AI solutions? You just touched on it, so I don't know if you want to hop on after Eugene goes.
Over the last couple of years, we've been working to create a predictive model, which leverages our access to highly differentiated quotes data. We launched our first asset class. In fact, we went beta late in 2023 and worked with a set of early adopter clients to give us high quality feedback in terms of the data, in terms of the tools, in terms of relative value solutions that would help kind of enhance and decorate this data. More recently, in August of this year, we came out of beta, and now the municipal bond asset class is live, and we're actively training models for other asset classes across that fixed income spectrum.
Just want to add a little bit to what Eugene alluded to here during the beta period. We were very fortunate to have a series of clients that we work with who were able to look at what we initially thought was pretty darn good when we released it in beta back in December. And I kind of equate this to, look at our child, it's beautiful, but you need someone else to tell you where the blemishes are. And we were able to actually access that information through the contacts that we have and the interactions with our clients, and that helped us to really bring our models forward and identify some nuances that we were not otherwise able to do on our own, or might have taken us longer to do on our own.
Algorithmic biases, is there any somebody's concerns about that?
The predictive pricing model is trained on 3 key data sets: on quotes, trades, and reference data. Trades are absolutely a key input into the model because we see a trade as the truth, right? A trade represents 2 parties agreeing to a fair value of an asset. Hence, that is the truth that the model is being trained to optimize itself to approach. Quotes are incredibly valuable because a quote is a forward-looking data point. Before a trade occurs, there are typically multiple quotes that are exchanged between market participants. So with our unique access to the quotes data, Solve is uniquely positioned to essentially look into the future, right? So as we're seeing quotes, the model has a sense of what is the likely trade price, kind of given that key piece of information. Now, reference data is another key data set that's going into the model as well, especially for bonds that are less liquid, that don't have as many quotes, don't have as many trades. It's incredibly important to be able to identify comparable securities that the model could learn from, and this is where reference data comes in. What I think is also an important data point about the results of our model is the fact that the bias of the model is essentially 0, which means that the model is equally strong at predicting the bid side as well as the offer side of the market.
The criticality of being able to identify comparables, especially in the muni space, is something that is really important, and it's something where we're able to leverage our underlying obligor database, our underlying sector designations that we've done over time. As we all know in this group, munis are relatively illiquid when you look across the market, right? We have over 1 million bonds outstanding. We're providing solve price for over 900,000, 99% fixed coupon bonds. And the majority of those bonds aren't trading on a regular basis, aren't being quoted on a regular basis. We're able to utilize the data that Eugene referenced, but then also leverage our database and identify comps in the marketplace, and that's a big part of the equation as we produce solve price.
Well, so this question is going to start with Tim, right? So when thinking about AI in general, AI solutions, what are the foundations of successful implementation and integration of AI solutions? human four-eyes checks, improved standardization, infrastructure, data ontology, etc.
In order for an organization to have a strong artificial intelligence base or discipline, a lot of important aspects are needed. And it really starts with a strong, talented team of people. You've got to have market participants, professionals that have been participants in the market, that understand how the markets work, understand how the different asset classes work, and in our case in the fixed income space, understand the relationships in data and how these securities trade. You also have to have strong data scientists who understand the appropriate models and frameworks to be used for the problem that you're looking to solve. You have to have strong developers and architects, development operations engineers, and quality assurance individuals to build the systems, to pipe the data that's needed in order to feed these models and then to generate those predictions and save them down to the database and ultimately provide them to our clients. And you need data analysts who are helping to cleanse the data, prepare the data, and analyze the results of those models over time. In addition to the team, you need to have good data. And when I say that, there are several aspects to that. You need good quality data, data that can be utilized without fear of it being blemished in some way. You have to have data that's deep, it's broad across the market and covers the different assets that you're looking at. You have to have good history with respect to that data so that you can train models and test them over long periods of time. Ideally, fortunately in our case, you also have proprietary data that others don't have that provide you with an edge in terms of your ability to come up with a prediction in this case. Next, you need a strong computational power in order to feed those models and to predict, in our case, on a real-time basis when we're thinking about solve price. You also have to have a strong back-testing framework so that you can test that model over time, look at its prediction accuracy over time, and then continue to monitor that prediction accuracy. So you're monitoring your systems, you're making sure that they're performing at the optimal level, constantly looking at the performance of the model, and then retuning, a process to retune those models in order to enhance or improve your prediction accuracy and have a spirit of constant improvement because you're constantly looking for ways to improve your prediction accuracy.
I just want to add to what Tim said, because I think what's really important there is this component of transparency. Tim spoke to the models, he spoke to the data, he talked about retuning and retraining the models. The transparency that we have associated with that is not just within the organization, but it's something that as we've been engaging with our clients and prospective clients, and they start to dive into the what, the how, and the integrity of what we do, we're able to bring that information forward and have those conversations in a really constructive way.
So actually, on that note, let's keep going in that direction. Can we discuss the data collection and what differentiates Solve PX? So Greg, we'll start with you, and then Tim, you had a note that you were going to jump in with quantitatively importance of cold data, et cetera.
So when we think about Solve Price, I think it is ultimately the data that differentiates what we're doing and how we go about collecting it and bringing it in. So first and foremost, there is security master information, which we're bringing in, which is available to market participants, and then trade data that's available to market participants as well. The third piece of the puzzle, the third leg of the stool, if you will, is our proprietary quotes data. Those three kind of legs of the stool are the foundational aspects of the data that's driving our models and what we do. The other thing that's really important from a proprietary data standpoint is our obligor database and our sector designation. Two critical components as Solve PX and the models are working are things that are really important to drive the output that we're generating, i.e. the predictive price.
Yeah, I would add to that. We've looked as a team at the predictive power of our proprietary quotes data, the real-time pre-trade quote data that Solve has as a core of its database. And we found the results to be very interesting. what we found is that approximately 40% of the predictive power of our AI model for solve price comes from quote-related features, so the quote data in particular. That's nearly as powerful as actual transactional data in the market. From an empirical standpoint, we took a look at all of the backtesting data that we've performed over time. So we recently published a white paper that's available on our website. And in that white paper, we talk about a backtesting process that we did over a 15-month period, which took a look at over 16 million transactions that occurred in the marketplace. And what we found when we looked at transactions that occurred in the market, we kind of split those transactions where we made a prediction for all of those. And we took a look at the bucket where we had quotes preceding a particular transaction, but there was no trade preceding that transaction. It could have been a quote, but no trade on the same day of the transaction, within 5 business days, or within 20 business days of the actual transaction. And what we found is that our prediction accuracy increased significantly by about 35%, just by the fact that there was quote data associated with that particular bond prior to the transaction occurring. So we found it to be incredibly powerful. Additionally, we found that the best prediction accuracy that we have was the cohort where you had both trades and quotes. That was by far the best prediction accuracy that we experienced. And when you take a look at both of those, where you have both trades and quotes and where you have only quotes, what we found is that we had a direct, significant positive increase in our prediction accuracy on well over 50% of the 16 million plus trades that we looked at in the market, and a positive result or positive impact indirectly on essentially the entire population of trades.
Hey, Tim, I want to put you on the spot for a second. When we released our white paper, I think our MAE was about 6.9 cents, or 6.9 basis points on yield. And I know since then, I think the paper was released in August, so here we are a bit later in the year. Can you talk a little bit about where we are now in terms of our MAE?
Sure. So one of the things that we do as an organization is continuously monitor the model. In fact, it occurs on a daily basis where we look at transactional activity that has occurred in the data. We've predicted those trades before they happen. We do this on a backward-looking basis. And what we find is that our MAE has continued to improve over the course of this year. In fact, right now, our model is hovering right around 5.5 basis points on the overall market in terms of prediction accuracy. So we continue to see our models improve in strength as we continue to improve our prediction capabilities and retune the parameters of the model.
That's really powerful. So data obviously plays a huge role in it, but there's all data feeds the models. So Tim, can you start us off and talk about the prediction model itself, and then I'd like to hear maybe Eugene about how that's actually different from the AI model.
Sure. So the prediction model for solve price is designed to predict the next trade for a particular bond, a particular, in this case, municipal bond, since we're starting in the municipal marketplace. And what the model predicts is a bid side, it predicts an offer side, and it predicts a mid-market price for the bond. We predict a price, we predict a yield, and we also predict a spread associated with that price. And it's a spread to the appropriate benchmark, whether it's taxable or tax exempt, depending on which portion of the market that we're looking at. In addition, we create these predictions based on whatever trade size is relevant to our client. So from a backtesting perspective, we're able to predict precisely on the size of the transaction. This is a really important distinction in terms of what we do. We predict on over 900,000 municipal bonds that are currently outstanding, which is the vast majority of the market. And when we look at that model, That model is fed by several different data sets, if you will. We look at the pre-trade quote data that Solve has. It's proprietary to Solve, real-time quote data, the trade transactional data that's out in the market, reference data, and we also do look at general levels of interest rates. What we find with respect to the model itself is that it is unbiased in terms of the fact that we neither overprice nor underprice trades in the market.
Right, Eugene, how's that model different than the quote-unquote AI model in Softwares?
So one of the questions we often receive from clients is AI being a bit of a black box? How can they get comfortable around the results of the model? And there are a few things that I would say that sort of address that question, right? So first of all, the reason why our predictive model is able to achieve such a high level of accuracy is because it looks at a world in many more dimensions than what a typical linear sort of traditional pricing model would do. A linear model will generally look at a fairly finite set of parameters, mainly because it's built by a human. There's only so much. There's only so many parameters that you could code around and quantify their impact on the ultimate price, right? So a more traditional approach involves matrix pricing, where an evaluator will look at sort of a few key parameters, such as rating, industry, maturity, and some additional characteristics of the bond, to essentially put it in a box, and that will drive the sort of the indication of fair value of that particular security. AI does this on some really serious steroids, right? So it looks at over 300 different feature inputs, right? Which means it's not just limiting its worldview to a handful of parameters. It's basically looking at the world in 300-dimensional space to look at data points that are relevant to the security that's being priced, in addition to looking around that bond and trying to pick up relevant data from other securities of the same issue or from other comparables in the market. Now, in terms of how do we get people comfortable around the results of the model, I would say a few things, right? So one is our platform is all about transparency. So the idea is that multiple data sets live side by side. When you're looking at a predictive price in the same ecosystem, you're able to see actual real-time quotes that we're observing in the market. You're able to parse messages that your firm is receiving directly from your trading counterparties. You're able to see trades. So for corporates, you're able to see trace data. For munis, you're able to see MSRB data. And that all lives side by side with the predictive price, in addition to being able to look at comps and look at observable data for comparable securities as well, right? So that's the first point. The second point is that the model also produces a confidence score, and that's really important, right? So the confidence score is going to be highly correlated to the expected prediction error of a particular security. So the higher the confidence score, that obviously means that there's more data that's available, either for that bond or around that bond, which drives the confidence of the model. That's an important point, which gets our clients comfortable with the results of the model. In some cases, clients will use the higher confidence securities to drive some of their lower touch strategies, while the other cohort sort of bonds with like a slightly lower confidence score will be used in more high-touch strategies, which require a little bit more research. And the final point is backtesting, right? So we're incredibly transparent when it comes to the results of the backtest. We published a white paper. We're working on another one right now, which slices the Muni universe across kind of many dimensions, and highlights the results of the predictive model, which again kind of gives customers a lot of comfort around the results.
Just to add one other piece to that, when we're out in the marketplace speaking to constituents, there are kind of different groups of people that are going to assess what we're doing and want to understand what we're doing. So there are the folks in the room who are going to want to dig in and really understand the model and what we're doing, the predictive model and the AI and how we're utilizing it, because there's the black box component. So how do we get them comfortable with that? And we're very comfortable sharing that information. And then there are the folks who are looking at the numbers. At the end of the day, they're just looking at the predictive price. Is it good or is it not good? And that's what they're asking. So when they're testing us, when they're trialing our platform, when they're looking at it against 3 months of trade data, they want to know how good we are for the bonds that they care about. And we are able to, for their back testing purposes, to deliver to them the information that they need based on the trades that were conducted, the size of the trades that were conducted. We're able to deliver that information. But more importantly, prospectively, when they become a client and are using our platform, they're able to see the power of the predictive nature, because they're getting a comfort level of what we've done through back testing. But then number two is with the introduction of a confidence indicator. And that's also going to give them greater comfort as they're using the predictive price.
And the size of a trade is obviously a very important driver of the predictive price as well. As we know, execution at a more institutional size will significantly differ from execution at a more retail size. So the model does a few things, right? So there's a concept of a representative institutional size. There's a concept of a representative retail size, which clients are able to see directly on our platform. But in addition to that, those could be highly customized. So some of our clients have their own definitions of what is an institutional size and what is a retail size. So we're sending them data feeds that are driven by their definition of that size. And others are requesting a very bespoke size. So for every CUSIP, they're pinging our API and they're asking for this specific security, for this very specific size, give me a two-sided market. Give me the bid side and the offer side.
How does the inclusion of relative value in sol price enhances usefulness in identifying trading opportunities? And the corollary is, what are the practical applications of sol price in terms of like rel-val for portfolio managers and traders?
So one of the questions that we get is around relative value. And intuitively, when you look at solve price, whichever side of the market that you're on, whether you're a trader, whether you're a portfolio manager, it's all about, at the end of the day, executing at the best level that you possibly can. But it's also the ability to identify alternatives in the market. Am I buying the best bond for my needs right now or my client's needs? And with the introduction of solve price, what we're able to do is show the price not just for the bond that you're interested in, but for other comparable bonds as well in the marketplace. So from a trader's perspective, that's very relevant. When you think of a PM, a portfolio manager, her needs may be slightly different. They may be focused on a specific market segment, and they want to see kind of what's the best value out there for the bonds within that market segment and the maturities that I care about. Or taking it even a step further, more broadly, is there's a broader mandate. We were originally focusing on a specific sector within munis with a certain maturity range. Maybe we need to shift sectors. Maybe there's a change in value opportunities that we are seeing, and it's by virtue of obviously going to be some of their research, but also more importantly, being able to look at solve price, whether it's on a specific bond, on a specific issuer, or going more broadly around sectoral activity, or even further thinking about it within given states. So it's all about identifying where the best value is for the portfolio, and or where the best value is for the trader for the benefit of the retail client or the institutional client.
Yeah, there are a lot of great points. We've had many conversations with our clients and prospects around relative value. I think part of it is exactly that, right? So they're not necessarily looking for specific QSIP, specific security. They're looking for a theme, right? So they want to be able to look at particular credit characteristics, particular state, particular maturity, and then identify within that cohort which bonds are rich and which bonds are cheap, right? So whether they're looking for a new investment or they're looking to rebalance a portfolio and move something out that's sort of rich compared to something else that might be cheaper in the market. So we've always seen solve price as kind of that foundational data set, which on the one hand has a lot of value when you're trying to ascertain fair market value of an individual security, but also it naturally kind of rolls into these relative value analytics, right? So when you're looking at a cohort of securities that look and feel the same, you're able to identify which ones are rich, which ones are cheap, and then you can elevate that and do analysis at a cohort basis, cohort versus a cohort, where you could say that hey, these two cohorts, historically they've trended in a certain way, right? So historically, perhaps they traded 100 basis points apart, but there's some kind of dislocation in the market that our customers are looking to take advantage of, right? So by easily being able to roll things up into themes and cohorts, they could very easily identify kind of these dislocations and act on them before the market corrects.
One of the interesting conversations that we've had with one of our clients around relative value is the ability to look at, as she was saying to us, specific cohorts, types of bonds that she is interested in, and the use of solve price there. What she also found incredibly valuable is the inclusion of solve quotes as well. It not only told her where we thought, just on a bond by bond basis, where that value might be, but it also, by virtue of she was receiving thousands of messages, and for us to be able to parse and deliver those messages back to her, she was then able to identify where there's a market and be able to execute on those, which was incredibly valuable for her in terms of managing her portfolio.
These are all great points, and when I think about my in a prior life, I was on the buy side, and there were a lot of demands there. You're constantly looking to put money to work. You're constantly looking for ways to optimize your portfolio and your yield. And the data that Solve has that can bring to bear to perform these relative value analytics is just tremendous. So the ability to filter down cohorts very specifically to what your needs are, whether you're looking at particular points in the yield curve, you're looking for particular coupons, particular sectors, particular geographic locations, even down to particular credits, right? We're able to do that type of filtering to provide that list of alternatives that you're looking at, whether you're looking to free up some cash or you're looking to put money to work, and to be able to perform that type of analytic on that type of data is just incredibly powerful.
Technology and innovation question. How do you foresee the role of machine learning and AI evolving in the fixed income market beyond what Solve Price currently offers? Maybe we'll start with Tim.
In terms of AI and how it's going to evolve and change in the market, I think we're only just starting to see the effects of artificial intelligence and machine learning for sure. Clearly, we're working on predictive pricing, right? This is what Solve is focused on right now. We certainly have plans to proliferate that across all of the different fixed income asset classes, so that we have better analytics, better predictive capabilities across the fixed income market. And that's both here in the United States and abroad, right? As we think larger across the international landscape in different currencies. So putting these types of analytics in the hands of our clients is certainly an exciting prospect for us. Will it ultimately lead to electronification and more automated trading practices in the fixed income marketplace? Probably over time. So I think a lot to come in this particular area.
So firms in the financial services industry are not notorious for being early adopters of new technologies. What have been some of the challenges in gaining market adoption for AI-driven tools like Solve Price, and how has Solve addressed them?
So what has been different with Solve Price is the objective nature of the predictive quality of this predictive price, right? So even though some clients, they resist being early adopters, and they kind of stay on the sidelines to see what others kind of will do first. When you're able to objectively quantify the impact of the predictive price, when you're able to look at historical trades and basically demonstrate where the model would have predicted that trade should clear, that's a very sort of clear way of demonstrating ROI, which I think is certainly making folks think and get off the sidelines.
One of the things that we have seen with over the years in the muni space, I'll speak to, is there's always that I don't want to be first. What's been very interesting with Solve Price is that there are a number of firms who are trying to do their own predictive price on their own right now. And that's more in response to a smaller group of firms that were able to successfully deploy this type of technology in the marketplace. So I think the reluctance, the concern about being a first adopter is probably less problematic. But I'll flip it around a little bit. One of the things, and I think this benefits us as we think about our platform and what we do and the results that we generate, firms are being highly analytical when they're looking at a predictive price to adopt, because it's going to become part of their DNA as they go forward, whether it's for purposes of how they're going to execute, whether it's for purposes of kind of putting guardrails for their own models or even contributing to their own models. They need to get this greater level of comfort. And what we have seen as we've been out in the marketplace now for 9 months now, first in beta, now in production, is that clients will do that assessment, and as they gain the comfort level with what we're doing, because they see continued improvement and they continue to see strong results with our models, that kind of barrier to adopting has gone down. The flip side is it's unfortunately taken them a little longer in some cases than we would like, but that has to do with the analytical nature, and again, it becoming part of ultimately their strategy, whether it's on a portfolio side or a trading side.
So to that point, Greg, they're evaluating Solve Price, they're evaluating other solutions that are out there in the market. So how does Solve Price differentiate itself from other AI-based pricing tools that are currently out there?
So how we think about differentiation is the proprietary data that we bring into our platform and into our models. Everyone has access to trades, everyone has access to reference data. Not everyone has access to quotes, and Solve Quotes, it's something we've been doing for many years across multiple asset classes. The other components of proprietary data that we have that are highly valuable are our obligor database, which allows us to be able to look across market in a way that some others aren't able to, and then our proprietary sector designations, which we've done over the years as well. Those are critical components in terms of how we differentiate, aside from then getting into the model itself.
So I would add a couple points to that. So certainly a key differentiating point is the data that goes into the model. The other couple things I would add is one, we have a very large global team, right? So we're 160 plus people, most of which are sort of more on the technology, AI, and data side of things. So there's a tremendous amount of R&D that's happening behind the scenes to continue pushing the models to see what's possible in terms of the accuracy, to continue pushing the same construct, the same predictive model into our other asset classes, to develop relative value analytics, to develop all sorts of data feeds that our clients are coming in and asking to consume the data in many different ways. So I would say, in addition to definitionally having the best possible outcome of the model, kind of given the data that's going into it, we're able to, we're listen to our customers. We respond and help them get the data in ways that make sense to them, and continue listening and continue building the tools around soft price.
I'm going to say it slightly differently, but I think the same point. As someone who interacts with the market on a regular basis, I think another differentiating factor for us is the ability, based on our team, to be responsive to the market. It seems that literally every client or every prospect that we're going to speak to wants the data a certain way, in a certain form, and the ability to meet those demands and meet those needs literally in real time is what we're able to do by virtue of the fact that we are 160 people worldwide.
What are the, if any, regulatory concerns that the fixed income market is considering when looking at AI-based solutions in general, or predictive pricing solutions in particular? And what are the potential risks? Let's start there.
So we're having regular conversations with our clients, especially around some of the regulatory issues that they're thinking about. Typically, when our clients build a pricing model to price kind of liquid assets, they have to vet their methodology with regulators. But given that AI is a bit of a black box, it doesn't lend itself to sort of that same process that the regulators are used to. As a result, they have to kind of think about a different paradigm when it comes to explaining the accuracy, the results of the model to regulators. And I think what everyone is realizing and getting comfortable with is that when it comes to AI, it's really impossible to trace what sort of happens inside the black box, right? So you're not really going to be able to explain that in any meaningful way. But AI, the predictive model does kind of offer a tremendous amount of transparency through backtesting, through looking at the actual results of the model, which you're able to do over significant periods of time. And so it's less about looking at the inputs, more about looking at the outputs, and explaining the predictive power of the model across different yield curve environments, different volatility environments, and slicing and dicing the results in all different ways to make regulators comfortable.
So with regard to Solve Price, we've been asked the question, are you an evaluated pricing service? We are not. We are a predictive price. We're looking to where the next trade will occur. We're not looking at it based on a point in time, specific point in time, looking back and for purposes of valuing the book at that point in time. It's indicative of what's going on in the marketplace from both a trade perspective, a quotes data, looking at comps in the marketplaces. It's dynamic, and that's what's really important about our model and Solve Price.
Some other features associated with our model that incredibly important to keep in mind is that we individually predict every price that we come up with, meaning we individually predict the bid side, the offer side, the midpoint of the market. We individually predict when a particular trade is going to occur. We individually predict a price based on a particular trade size. So we don't take a look at, for example, predicting a spread in the market and then keeping that spread static and then repredicting a price just based on applying that spread to the current benchmark rates that are in the market. That is not how we operate. We take the most current data available at the time of the prediction. We feed that into a vector that feeds the prediction model and comes out with a specific price at that specific point in time for the side of the market that you're interested in, for the trade size that you're interested in. And it's a very differentiating point, we believe, in terms of how we do things, and it lends to greater accuracy and lower prediction error.